Hello, 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 hello. Yeah, can you hear me first of all? Okay, okay. So the sample paper is an Allen paper. I have already shared it. You should check the posts. Have you got the paper so far? One second. I will share my screen. Okay. I hope everyone can see my screen now. If you have not got the paper, you need to go to one of the posts or also on Telegram. You can go to Telegram on my channel and you can see paper 536. Okay, so it is paper number 536. I have shared two papers. I have also shared the links on YouTube. It is also there on YouTube. So just find it out. I will wait for some more students to join before I start discussing anything. But find the paper. You have a couple of minutes. Find the paper. Okay. Vector's next lecture will come tomorrow. NJ. Izuzi, thanks. Revision was good. I'm happy that your revision was good. Do the entire playlist for coordinate geometry. Don't just do straight lines. Do everything. Okay. I will be making more videos for PYQs for coordinate geometry, and vectors next lecture will come tomorrow. Like before I start discussion of the paper, okay, Mr. White, you have got the paper, right? Okay, I think he got the paper. Fine. So I will wait for some more time for the other people also to join in. You guys can share the link in Telegram actually on the channel. Try and share the link on the channel so that more people can also join in. I don't want only 4 5 people to see it. Okay. So one second, I'm just trying to figure out how to share the link. Okay, I will share this complete link itself on Telegram, and hopefully some more people can join, and then we will start. Okay. Uh, right. So right now we have 5 people. Okay. I will begin. There is no point in waiting. If people have to come, they will watch it later also, right? So, have you guys looked at the paper? Have you seen any of the questions in the paper? If you have tried something, let me know which question you want to start off with. So I want to discuss the math section first. The first question in the math section is a complex number question, right? So have you guys tried those problems? Question number one, the complex number problem. Okay. Did you solve the complex number problem? Could you solve it? First question, the complex number problem. So the question actually says ABC be three distinct complex numbers with mod A, mod B, mod C is 1. So mod A is equal to mod B is equal to mod C is 1. And ABC are three distinct complex numbers. And what else is he saying? He is saying Z1 and Z2 are the roots of this equation. Z1, Z2 are roots of AZ square plus BZ plus C is equal to 0, right? With mod of Z1 equal to 1. It is given that mod of Z1 is equal to 1. Okay. And now the question that is asked, P and Q are points representing Z1 and Z2 in the complex plane where angle POQ is equal to theta. So P represents Z1, Q represents Z2, O represents origin, and angle POQ is equal to theta. That is given to us, right? So what can we do here? Anybody has any ideas? What can be done for this question? You can comment in the chat and I will be able to see it. Vieta's relation is correct. So first of all, anytime you have roots of a polynomial, you can always say z1 plus z2 is equal to minus b by a, and z1, z2 is equal to c by a. So that is valid even if the equation is a complex number equation. This is not a normal quadratic equation. Normal quadratic would have been ax squared plus bx plus c where x is real. This is a quadratic in complex numbers, but Vieta's relation is always valid. Okay. So from here, from this and from this, that mod z1 is 1, I can conclude many things from here. Okay. So first of all, what I will do, I will take mod on both sides in this. So I will say mod of z1, z2 is equal to mod of c by a, right? And a, b, c are three complex numbers with modulus 1. So obviously this is going to be mod c by mod a, which is going to be 1. And this side is mod z1, mod z2. And therefore mod z1 is also 1. So mod z2 is coming out to be 1, right? So basically by Vieta's relations, we have figured out that mod z1 is equal to mod z2 is equal to 1, right? Okay. Now think about it. What else is given in the problem for us? We have basically POQ angle was given as theta, right? POQ angle is given as theta. So we will need to use that relation somehow. So we will come to that in a bit. Before that, I also wanted to do a modulus on this, because so far what have we done? We have done modulus on the second one, right? So if I do mod of z1 plus z2, that is equal to mod of minus b by a, and mod of minus b by a is also mod of b by mod of a, because negative 1 has mod 1. So this is also 1. So we are also getting mod of z1 plus z2 is equal to 1, right? Okay. So from here, what we can do, is use this to get one of the options. The way we do it is we square it. So we say mod z1 plus z2 whole square is 1, and that there is a standard property of complex numbers. Mod z square is z z conjugate. Right? So mod of z1 plus z2 whole square will be what? Z1 plus z2 times z1 plus z2 whole conjugate is equal to 1, right? Now, think about that. If we have z1 plus z2 times z1 plus z2 whole conjugate is equal to 1, that means z1 plus z2 times z1 conjugate plus z2 conjugate is equal to 1. And we already know mod of z1 is equal to mod of z2 is equal to 1. Therefore, mod of z1 square is 1, which means z1 conjugate is 1, which means z1 conjugate is 1 by z1. Right? Similarly, z mod of z2 square is 1, which means z2 conjugate is 1, and so z2 conjugate is also 1 by z2. So in this relation, I can write it like this: z1 plus z2 times 1 by z1 plus 1 by z2 is equal to 1. And now what do I get from here? See, if you multiply it out, you will get 1 plus 1 plus z2 by z1 plus z1 by z2 is equal to 1. So basically what we are getting is z2 square plus z1 square by z1 z2 is equal to minus 1. Correct? And basically what this means is z1 plus z2 whole square minus 2z1 z2 is equal to minus z1 z2. And this means that z1 plus z2 whole square is equal to z1 z2. This is a result that we have gotten after a little bit of work. And now we can say minus b by a whole square should be c by a because of Vieta's relation. So we get b square by a square is equal to c by a, or b square is equal to ac. And notice that that is one of the options that was there in the question. We had to check that b square is equal to ac. Right? So we already know mod of z1 plus z2 is 1. We know that D option is correct. We know A option is correct. And now we have to do the geometry. How do I do the geometry here? So let's draw the figure. We have z1. Modulus of z1 is 1. Mod z1 is 1. Mod z2 is 1. Modulus of z2 is also 1. And this is my point P, and this is my point Q, and this is my point O, which is the origin, right? And this angle here is theta, right? So the way the rotation theorem works, the way you do rotation in complex numbers, is you write z1 minus 0 by z2 minus 0 is equal to mod z1 by mod z2 e power I theta, and this is like a anti-clockwise rotation, right? So we are getting z1 by z2 is equal to e power I theta here, right? So this is a relation that we get by rotation theorem, correct? And in the problem, we already know that mod of z1 plus z2 is equal to 1. Right? So we can, from here we can say z1 is z2 e power I theta, right? And we know mod of z1 plus z2 is equal to 1. We have already seen that before, right? So now we can write this as mod of z2 e power I theta plus z2 equal to 1, which means mod of z2 and mod of 1 plus e power I theta is equal to 1. But mod of z2 is anyway 1. So this becomes mod of 1 plus e power I theta is equal to 1. And if you convert it into cos and sine, what we will start getting now is the angle theta, relation on the angle theta. So think about it. This is 1 plus cos theta plus I sine theta. That is 1 plus e power I theta. This modulus is 1. So what this means is we have here, this can be written as 2 cos square theta by 2 plus I 2 sine theta by 2 cos theta by 2, and this modulus is equal to 1, right? And we can take 2 cos theta by 2 common, 2 cos theta by 2 modulus common, and inside we have cos theta by 2 plus I sin theta by 2 whole modulus is 1. But this complex number anyway has modulus 1. So this is anyway gone. We know modulus of this is 1. So from here I am getting mod of cos theta by 2 is equal to half. Mod of cos theta by 2 is half, means the theta by 2 angle is 60 degree or pi by 3, and therefore this angle must be 2 pi by 3. Theta is 2 pi by 3. So that finishes off the problem. Right? That gives us the last option that we needed. So here option B is also correct. And PQ, if I want PQ, I can easily find by cosine rule, right? Cos theta. So what I have gotten so far is this situation. This is 1, this is 1, this is 120 degrees. And I need to find this, right? PQ. So obviously I will do cosine rule. Cos 120 degree is equal to 1 square plus 1 square minus PQ squared by 2. And this is minus 1 by 2 is equal to 2 minus PQ squared by 2. So we are getting PQ square is equal to 3 and PQ is equal to root 3. So basically all the 4 options in this problem are correct. And I hope you have understood how we solved the problem. Right? Is it clear what we have done? I hope it is clear what we did for this problem. Which question do you think you guys are struggling with? Tell me which questions you want to discuss. We have done question number 1, which was the complex number problem. It involves some steps, but it is pretty easy actually. Nothing major was there. You can put it in the chat, the question number that you want to discuss. We will discuss that particular question. Unless you try the questions, guys, we cannot make any progress and you cannot improve. The reason I have shared the paper is because you need to try it before coming to this session. Today is the first session, so it's fine. But whenever we do the live streaming session, I expect you guys to have tried the problems before and come. Otherwise, there is no point for this course. Right? Which question are you saying, MJ? Question number 3. Uh, right. Okay, question number 3 is the determinant matrix question. Right? I will do question number 3. I can also discuss 5 and 6. Uh, Keshav is saying I'll be dedicating December January to volume 5. It doesn't matter. You have to solve enough problems. You have to solve many papers. Okay. You will not be able to decide which is a good problem, which is a bad problem. You can't decide that, it's not in your control. What you can do is solve a lot of test papers. Okay. So solve enough papers, join the channel here. I will be discussing a lot of papers and I will be sharing a lot of test papers. So you can go through the problem solving sessions that we do, and that should also help you. Okay. So, okay, I'll discuss question number 3, but I will not do the whole thing. It is actually not very difficult, question number 3. So I'll just give you the idea of what is happening here. Question number 3 says, uh, M be a non-singular matrix of order 3. M is non-singular. In matrix and determinant chapter, you need to know the meaning of every term. So what is the meaning of non-singular matrix? It means that the determinant of M is not equal to 0. Okay? Of order 3, the next thing that he says is M inverse is given. M inverse is given to be M inverse is given to be 3, 4, 5, 4, 5, 3, 5, 3, 4. 3, 4, 5, 4, 5, 3, 5, 3, 4. Right? Okay. The next part that is given to us is, okay, that's it. And now we have to figure out many things, right? So first of all, if you look at the options, what are the things that they are asking us to find out? one thing that they're asking us to find out is that of M inverse, right? See, one of the options has, actually they're asking us that of M, not that of M inverse, right? That of M they're asking also M power minus 2. Then what else are they asking us? 36 times adjoint of M, minus 36 times adjoint of M. Okay, so minus 36 times adjoint of M. And fourth thing is absolute value of the 15 times trace of adjoint of M. Okay, so 15 times trace of adjoint of M and the absolute value of that, right? So think about it. If you knew your adjoint of M, then you can do all of this stuff nicely. Do you agree that adjoint of M is important to figure out here, right? So what we will do here is remember our standard properties of matrices. We know that M inverse is 1 by det of M times adjoint of M. Right? You know this, right? This is the definition of M inverse of a matrix, correct? So first of all, what we will do here is realize that you already know what will be det of M inverse. This is a property that everyone should be aware of. Det of M inverse is 1 over det of M. Right? This is something that is a standard property. So if one of the options is asking us for det of M, all I have to do is find the det of this matrix. Inverse matrix is already given to us. To find the det of that matrix, if you find det of M inverse, that will be 1 over det of M, right? So when you do the calculations, it will come out that det of M inverse is actually equal to minus 36. This det is minus 36. So if this det is minus 36, that will be equal to 1 by det of M. So therefore, det of M will be equal to minus 1 by 36. So that is an easy solution for one part of the problem, right? Now notice that if somebody gave you M inverse, M power minus 2 is super easy to find. Why? Because M power minus 2 is simply M power minus 1 times M power minus 1. Right? M power minus 1, which is your M inverse, you just have to multiply the inverse with itself one more time. Just multiply it. And that will give you the M power minus 2 matrix. And you will realize that M power minus 2 matrix will be the correct option. 50, 47, 47. Option C that you are seeing, option C is correct. That is the product of M inverse with itself. So option C will also come very easily for you. Okay. So first of all, option B and option C should be obvious to anyone who has done a little bit of matrix. Okay. Now let's think about how to find adjoint of M. So we know our property that adjoint of M is equal to det of M times M inverse. Right? So we already know det of M. What is det of M? It is minus 1 by 36. So we know that adjoint of M becomes minus 1 by 36 times M inverse. Right? Okay. So M inverse matrix was already given. So technically, don't you already know the adjoint of M matrix? The adjoint of M matrix is already known, right? Because M inverse was already given to you, correct? So if you know the adjoint of M matrix, then what you need to do is bring the 36 on the other side, and you will say minus 36 times adjoint of M is equal to M inverse, right? And then what we have to figure out here is trace of adjoint of M. That is one part of the problem. So trace of adjoint of M. Trace means what? Trace is the sum of the diagonal elements, right? So trace of adjoint of M would be trace of minus 1 by 36 of M inverse, right? And M inverse matrix, if you see, it was given to be 3, 4, 5, 4, 5, 3, and 5, 3, 4. So it will be minus 3 by 36 plus 5 by 36 plus 4 by 36, right? It is very simple. It is minus 1 by 36 is multiplied on each element, and you just add the diagonal element. This comes out to be the trace of adjoint of M, right? So once you figure out the trace, the question is sort of over. Like actually, you can easily check all the options now. The trace will come out to be minus 1 by 3. So 15 times the trace will be minus 5. So absolute value of the trace will be 5. And actually, all the options will come. And the whole question basically depends on a single property, that adjoint of M is equal to 1 over det of M into N inverse. This property, this rule, this definition is enough, right? So that is your solution for this question. If you look at question 5 is what? It is a vector question, right? This is a nice question. You should think about it. Have you tried solving question 5 yet? If anybody has tried solving 5, tell me what you have done so far. Usually, are you there? What did you try in 5? See, uh, it's not a very difficult problem, but there is one thing at the end that is required. Okay, so I will tell you that. So first of all, you have mod A is 2, mod B is 1, and A is perpendicular to B. Mod B is 1, A is perpendicular to B, and C is a unit vector. So first of all, you should know that mod C is 1, and C makes 60 degrees with both A and B, I think, right? Both A and B. And it is also given that C is equal to X times A plus Y times B plus Z times A cross B. I think that is the statement of the problem, yeah, right? And then we have to find all sorts of relations between X, Y, and Z. So one option is 2x is equal to y. Another option is uh, another option was x is equal to 2y. Then you have third option is y is equal to 4z square, and fourth option is x plus y plus 4z square is 3 by 4. Okay, right. So what have you tried? Tell me. Yeah, scalar triple product is the right idea, but that is only one idea. You have not missed out, you have not fully done everything that you could have done here. So what I would say here is, notice first of all what information do you have, right? C makes 60 degree with both A and B. So what is A dot C? A dot C will be mod A mod C cos 60. So it will be 2 into 1 into cos 60 half. So it is 1, right? And what is A dot B? A dot B is 0 actually, because A is perpendicular to B. What is B dot C? B dot C would be what? 1 into 1 into cos 60. So it is half. Right? So we know all the three dot products that are possible. We know A dot C, A dot B, and B dot C. Right? Great. So from here, before you do triple product, what you should do is try to do dot product with A, dot product with A vector, with B vector, and then finally try to do dot product with A cross B. So what do I mean by that? So first, if I do dot product with A, I will get A dot C is equal to X mod A square plus Y A dot B. And you should realize that Z A dot A cross B will become 0. This part becomes 0. So what am I getting? A dot C already I know the value. No? So 1 is equal to X mod A square is 4, right? Plus Y A dot B is 0 and this is 0. So notice that we are getting 4x is equal to 1, right? Correct? So we are getting x is equal to 1 by 4 directly, no? X is equal to 1 by 4 comes immediately. 4x is equal to 1 is coming. No? The next step would be doing dot product with b, right? So let's do dot product with b, same relation. Okay, same relation, do a dot product with b. So let's see what comes. You should get b dot c here. B dot c value is half. That will be x times a dot b is 0 plus y times mod b square and plus 0 here. So mod b square is 1. So you're getting y is equal to half. So do you realize that I have gotten x and y values immediately? So I can check now that 2x is equal to actually y. So this option is correct. This option is incorrect, right? And now we have to do think of the third part, which is dot product with A cross B. Izuzi, are you following what I am doing so far? Is it clear? Now do a dot product with A cross B. So C dot A cross B, right, would be equal to, now which ones will disappear? This will disappear because A dot A cross B is 0. B dot A cross B is also 0. And you will get Z, and this side it will be A cross B dot product with A cross B, right? And this is the triple product, right? This is the triple product. So far, we don't know the value of the triple product, right? This is like your CAD triple product. And here we have Z A cross B. So A cross B will be simply mod A mod B. So it is Z mod A square mod B square. Right? So what we get here is Z into 4 into 1. So 4Z is equal to triple product. Right? Now this is the point where you need a little bit of theory, and that theory is knowing this formula. See, right now I cannot find the triple product. No, I don't know the vectors. Unless you know the components and all, it is difficult to find the triple product. So you will find it difficult to find the value of Z. Right? So here I would give you this result that you should always remember, and this result is something that can be proved, and this we might prove in our vector classes. As we go ahead to vector triple product in my vector series, I will try and prove this result for you. You should know this. Triple product square is equal to basically the determinant. The determinant is written like this: A dot A dot B, A dot C. And now you have B here, C here, and here also it is basically B dot A, C dot A here, and here it will be B dot B, here it will be C dot B, here it will be B dot C, here it will be C dot C. So this result, if you are aware of, then your life will be easy because you will be easily able to find the scalar triple product. And if you find the value of scalar triple product, you will get the value of 4Z, right, in the problem. We have already done that part. So this result is going to be useful for us because we already know what is all of this. Right? We already know A dot A is mod A square. Right? So what was mod A? Mod A in the problem was, I think, 2. Right? Mod A was 2. So this determinant is basically 4. A dot B is 0. A dot C and all, we already found all the values. Right? So we know it is 401, 01 half, 01 half, and the third row is 1 half and 1. 1 half and 1. This is the value of the determinant, and this is actually mod of triple product square because of this result. And this result, please make a note of this. This is super useful in problems. Like here, if you know the value of triple product, you can find Z. We have already found X and Y. So the question is over if you know this. So we will do this in our vector series. When I come to the topic of triple products and all, I will do the proof of it. So stay tuned for that. And I hope you have understood this particular solution. Right? Okay. Uh, so I think there is only one person right now. Other people have gone. So we will continue probably in the next session. If nobody is here, then there's no point of the live stream. Uh, what I want you guys to do is solve the paper first. I will put out a exact schedule for when the streams will happen, and you can plan for it. Today was the first time we are doing it, so it might be a short stream, but later I will put a plan for it, and I'll put it on my YouTube channel also, and as well as on my Telegram. Sixth problem, what is the issue? Question number 6 is not very difficult, I think. Uh, what is he saying? If A, B, C are positive integers such that A, B, C are in GP, D by A is an integer. Okay. Arithmetic mean of ABC is B plus 12. Find the value of A plus B plus C. Okay. Fine. So what are the information that we know? ABC is a GP. So ABC can be written as AR, AR square, right? Because it's a GP. We know that B by A is an integer. So what that tells us is that the common ratio is an integer, right? Now what other information is available to us? He says that the arithmetic mean of A plus B plus C is B plus 12. So arithmetic mean of three numbers will be A plus B plus C by 3 is equal to B plus 12, right? Okay. And this we will simplify a little bit. We'll get A plus B plus C is equal to 3B plus 36. So I'm getting A minus 2B plus C is equal to 36. And now instead of A, B, and C, I will write A, AR, and AR square. A minus 2AR plus AR square is equal to 36. So I'm getting A 1 minus 2R plus R square is equal to 36. This is A into 1 minus R whole square is equal to 36. And now remember that A, B, C, and R, they are all integers, right? The question itself stated that A, B, C, and R are integers. So now it is very simple because I need to only look for integer values. No? So 1 minus R whole square could be 1, could be 4, could be 9, could be 36. And in those cases, A would be 36, 9, 4, and 1, right? And 1 minus R whole square, if it is 1, what you would get is 1 minus R is 1 or minus 1. 1 minus R is 1 means R is 0, but that is not going to be possible. So 1 minus R must be minus 1. So R must be basically 2. So if R is 2 and A is 36, you would get B and C would be 72 and 144, right? 36, 72, 144 would be the GP in that case. If A is 9 and 1 minus R is 4, so plus minus 2. So 1 minus R is plus 2 will give us what? R is going to be minus 1 and minus 2 will give us R is 3. Right? Negative 1 is not possible because it will make the terms negative. So this I will reject, and R is equal to 3 will give me 9, 27, and 81 as my GP in that case. Right? So notice that I am able to find A, B, C in all the cases. No? Because I'm able to take advantage of the fact that A and R are integers, so there are only certain ways in which I can get 1 minus R square, no? Product of a square. I hope it is clear, MJ. Now you should be able to find, no, multiple correct answers, because see, why? We are getting A possibilities are what? 36, 9, 4, and 1. Because 1 minus R square should be 1, 4, 9, and 36. 1 minus R square can be up to 36. No? I hope it is clear that you can do case by case now. All the cases will be solved. I have already done the two cases, the first two cases. If you take 1 minus R whole square as 9, you will get 1 minus R as plus minus 3 and A will be 4. And then 1 minus R is plus minus 3 will give us R could be negative something 1 minus 3 minus 2, or it could be 4. So if R is 4, then you will start getting A as 4, then B is 16 and C is 64. I hope it is clear. The reason you are stuck is because you are not taking all the cases. All the cases are the possible values of R such that A times 1 minus R whole square is 36, where A and R are both integers. Right? That is what you need to pay attention to. Okay. So there are not too many of you right now, so we will end the session for today. But any doubts in the first two papers, you need to attempt the first two papers for the next session. So I will plan the next session in the next few days. And please try the first two papers. I have already shared it on the YouTube channel as well as on Telegram. So once you have tried it out, we'll schedule the session and we'll discuss all the problems that you are getting stuck on. Right? If you practice the problems and papers that I will be sharing on a regular basis, your preparation will definitely improve. Right? That's all for now. I will see you guys next time. Hopefully, you learn something from these live streams. And yeah, I'll see you just next time. Thanks. Bye.